Good morning, Computer Science 2A. Let's try that again. Good morning, Computer Science 2A. Hey, there we go. That's better. You're not hiding behind a screen anymore. You actually have to talk. You actually interact. And that's how, hopefully, the rest of the year will go. So we have some lost souls. They can be on the merry way. So you should have seen on Eve that you are in group A. If you had no group or you're confused and you're here, that's perfectly fine. You can see we are filling up the venue in our capacity of 50%. So we're still fine following COVID regulations. As you have already seen, we have my colleague here, Mr. Situngu, which is going to be lecturing. You should remember him from last year. And then me, myself, I am Mr. Muganlaw. I'm the course coordinator for Computer Science 2A. So you can think of it as I'm going to be the primary lecturer, and Mr. Situngu is the other lecturer, co-lecturer. Not to say that he doesn't do a lot of work, he does. It's just that I have to check everything first. So any problems, you can talk to either of us, but usually it will go through me. If you have a problem with either of us, then there's someone else you can talk to, which is going to be the Deputy HOD of Computer Science and Informatics, and then obviously the HOD after that. So what we're going to do is going to go quickly through the learning guide. It is already on Eve. You should be able to download that. If you don't have access to Eve, but you somehow still managed to come here, that's fine. Make sure that you are registered so we can put you on. Some of you might be registering a bit late. Some of them might be having registration issues. All of that is perfectly fine. You understand that it happens, especially now coming back into campus. Things will be a little different than previous years. And not that you were here in previous years on campus, but from my experience, we know that problems do happen. And we do take that into account when we look at things like practical submissions, so on and so forth. So with regards to the learning guide, this version that's on Eve is not the final version. It will always be updated with the latest information. As we become aware of certain things, we will put that onto Eve, and the latest version will always be on Eve. It says this in the learning guide as well. Not that everyone reads it, but it is there. If you have any doubt about what is the current information, always go and look at the latest version on Eve. So if you download the learning guide today and you can update it as soon as class ends, which probably will, then obviously that version is now the one with the latest information. You need to make sure that you have the latest information. It is your responsibility to make sure you have up-to-date information. I personally cannot go to every single one of you and tell you what you have missed. It is your responsibility. My responsibility is to provide the content to you in a digestible way. Make sure that you understand what we're going to go through. So let's have a look at what we're going to do in Computer Science 2A. So Computer Science 2A follows along from Computer Science 1B, so 1A and 1B. And, excuse me, it's been a while since I talked so much, at least at this volume. So we continue from that. So obviously you had to pass Computer Science 1A and 1B. And it's going to be 14 weeks long, standard usual stuff. And obviously I'm going to be lecturing in English. Now, there are things here like the module outcomes, the assessment criteria. All of those things are very important. I'm not going to read every single one of those things to you. You can read in your own time. But basically, we're going to teach you a lot of things that you learned previously in C++. We're going to teach it to you in a different language known as Java. And also, we're going to teach you some best practices with design patterns. We're also going to do a little bit of GUI development, graphical user interfaces. Those of you who did informatics would know about this already. If you're doing informatics this year, in Infos 1A, whatever, because of the different degrees, then you'll obviously see that later in the year. Other things which are going to be important here is that you should know what Eve is. You used it last year to submit your practicals and do your exams and tests and so on. Hopefully this year we are not going to be doing online examinations. Going to be written assessments. And in the case of practicals, we will be doing in computer labs practical assessments. So Eve is always the primary mode of getting your content, not Blackboard. Blackboard is there just for the university to monitor things. And as you might have experienced last year, Blackboard isn't the best at doing a lot of things. It works, but not the best. So we don't trust Blackboard. We know better. So we have our own website. So Eve UJACZA, you log in there, and you have access to all the modules which you are registered for. There's also going to be a Discord server, just as you've seen previously. However, it won't be as actively maintained, or we won't be as active on that as previous, because you are coming to class now. Obviously, there's still questions and stuff can be asked there, but it won't be used as much as last year. And then you have your prescribed textbook. Now, there was talks of edition 12 coming out this year. At the point last year when I got told by our liaison whether or not this will be available at the beginning of this year, they said they weren't sure. So I'm not sure if the bookshops have 12. Anyone have 12th edition? Who has the textbook? No one. Okay. So that's fine, not a problem. When you go and buy 12th edition is obviously better because it will be more up to date, but you get 11th edition, also perfectly fine. If you get an older one, you had someone who studied here previously, or you can't afford to buy a new one, you get a second-hand textbook, that's perfectly fine. Just make sure that you follow along to the content that we teach, not what's in the old textbook. All right, then we come to the lecture information. So you can see our details there. One thing you'll note is, okay, the QR code wasn't there, but there's a link here that you can click that will open up your email client and email us both. Very important not to just email me or Mr. Situngu. Email both of us. We both need to know what the situation is. Very, very important. So when you email, make sure that you email both of us. And the next important thing is make sure that you fill out all the relevant information. Who are you? You are a computer science 2A student. What is your student number? Surname and initials. Why do I need those things? You are not the only class I teach. This is not the only class Mr. Situngu teaches. So if you say, sir, my things aren't marked, full stop. What do? I don't know who you are. I don't know what course I'm teaching you, but your things aren't marked. Now I have to go figure out who you are because you haven't told me your student number, you haven't told me your name and surname, so I have to figure out all of these things. So what do I send back to you? Please provide me with this information. So then again, we wait. If you give it to me in the first email, everything goes smoothly. Then I know what I'm dealing with. I know I can help you. All right, so here I am in earring 218, so you will have to figure out the layout of the university. But earring is basically above the auditorium, which is next to student finance, above student finance. And we're sort of in the back of the earring labs. This is where your computer labs are going to be. I'm sorry?
Do you have a mic?
No, I don't have a mic. No one was here.
You need mic.
Well, not anymore.
You
can
can give it to me.
You can give it to me and let me use it. So I am in earring 218 and Mr. Situngu is in earring 219. So the information will be updated. We also have a period of consultation. At this point in time, we don't have a definite date for that, but there will be a time when you can come and see us for whatever reason, related computer science 2A or other things, if you need help with other things. And we can help you with those specific things. Anything else you want to say? All right, so Mr. Situngu is going to take his leave. He will be teaching you more in the second term. I will be taking the first term of lectures. You will be seeing Mr. Situngu in the future, so don't worry about him. And you will be seeing him, especially in the practical sessions. So here, again, just make sure when you send in a query, don't expect me to answer at the same time. This is not your friend on WhatsApp. This is not your friend on Facebook. I'm not going to respond at the same time. So if you have an issue, we will respond to you, not at the same time. If it's a week later and I still haven't responded to you, then you can complain. But if it's 5 minutes after you sent it, obviously I have not seen it yet. All right, let's look at now the schedule. So with the schedule, what we have is a very spread out schedule, class every single day. So you'll see there's lectures on Monday, Tuesday, and Thursday, tutorials on Wednesday and Friday, and then the practical session on a Tuesday. All lectures, all tutorials, all practical sessions are compulsory. You don't get put into, oh, I can only attend the first period of my practical. It's all compulsory. Now, that being said, we do have a situation where you are in Group A or Group B for attendance on campus in the actual physical venue, but it doesn't mean you don't attend the lecture. Right now, hopefully if everything's still working correctly, this is being streamed on Blackboard Collaborate, and you can access the lecture that way. That means that you don't have to be physically in this venue when you are in group next week when Group B is here, but you are on campus somewhere, or if you're fortunate enough to have data at home, you can do that way. But it is expected to you by the university to be on campus. So you should be on campus somewhere to actually be able to do the content live on campus.
Sorry, just the battery's not working. I don't know, Sabrina, you can just carry on.
I'm just going to carry on, but next time you guys need to be here before I start.
Cannot close, and I think there's a lot of things.
Yeah, I know. It's going to be a lot of things. And then also, we talked to the guys last week already. We need the aux cable. I can bring my own aux cable, but I need the aux cable so that when I speak to the microphone, it records on my laptop.
The aux cable, no?
Yeah.
Okay,
So that's for next time.
okay, here's the battery. Oh, they got the aux cable.
So how the practical sessions work is usually you'll see that there is a lecture just before the practical session. That's going to be known as your practical lecture. We will teach you something that will be required, not in the practical that's due on that day, it will be due the next week. So that session is there for you to work in the computer labs. You have that time available with a computer in front of you. You can do the practical that's due next week, and you can ask questions. So if you're struggling with something isn't working correctly, you have that opportunity to actually sit and get help from an assistant or myself. Tutorials, sometimes we might switch out the tutorial for a lecture where we will do some theory content and then some practical content. We'll mix it up depending on if we need that time or not. Right, so again, more reading for you to do. I'm not going to go through every single one of those things. So one thing that you should note here is the first practical is tomorrow. And yes, you have a practical to do tomorrow. So we'll see what that is in just a moment. Yeah? So here we have the schedule for the term. Now this can change depending on what happens on campus in terms of access, etc. But this is so far what we envision for the semester. Now term 2 there's still some things I need to update there, so we'll look at term 2 in the future again. But for now, term 1. Just to confirm, everyone can hear me, right? Okay. So with term 1, you'll see there you will have lectures and tutorials, etc. Now things do change. If I see that some people are struggling with certain concepts, there might be, in terms of tutorials, I might swap things around. In terms of theory lectures, they are pretty much set. There's no real changes going on there. Thanks, guys. So you'll see the first practical that you have there is working with the JDK. What is the JDK? We'll talk about that in just a minute. Other things you'll note here is that you will see some places where you'll see revision. And revision is basically there's going to be a test that's coming up. So summative assessment opportunity 1, fancy way of saying semester test 1, is going to be there, and obviously we're going to do a revision before that actual assessment. Same thing goes for your practical tests. Your practical test will be after the recess. And then you'll have a second theory test. Yes, you heard right. You have 3 assessments this semester, not counting obviously your exam. 2 theory, 1 practical. And that's very important, as you'll see when we get to the mark distribution of the actual module. You'll also note that there's some days where there's timetable switches, where even though it's going to be a Thursday, you'll be running a Monday timetable. So obviously Monday will be a lecture in that case. So those are highlighted here. However, like I said, term 2, I didn't quite get through all of that, so that will still be coming through. Okay, I can't fix that because the guys already left. So in terms of your assessments, you have weekly practicals, which are compulsory. You have to do them. And as you know, we do conform to the BCS for accreditation purposes, which means that when you get your degree, and obviously it's not just as simple as getting a degree, there are some steps afterwards. But if you do your degree and your honors with us, you can be in the position to register as a member of the British Computer Society, which means that you are part of a group of people who have established themselves as certified IT professionals. It's on the way to get there. You don't automatically get that. You still have to apply for it, but you have less work to do than someone who studied somewhere else. We've got this accreditation since I was in undergrad, back when UJ formed, after RAO became UJ. So 2005, that's when I started. And we've had this accreditation since. We were the first in Africa to get that, and obviously subsequent universities have done that as well, but we maintain that. In order to maintain that, we have to keep a certain standard in terms of programming. You have to know how to program. That's what you came here for. You came to study IT, you have to know how to program. Now, speaking about what you want to do in life, that's something else we need to talk about. It's something that I would like to talk about, because when we online lectures, I don't get to talk about all that stuff. I just talk about lecture and we're done. But that's not all that I want to teach you. I want to teach you more about than just the content in the textbook, because the textbook isn't everything. The textbook is not going to teach you about life outside. All right. So you get your assignments, you get class tests. Class tests, we're most probably going to try and do it on Blackboard, but we'll see how we're going to do that, because I can't hand out physical things to you and take them back. Lots of issues with that. Then you have your 2 theory tests, and then a practical semester test, as well as one take-home practical assignment, which is over an extended period, and that's known as Practical X. We'll see what that is in just a moment. In terms of the mark breakdown, you can see there's 2 parts, your practical component mark and your theory component mark. Practical component mark is all your practicals, plus your practical test, plus that Practical X, that big assignment. And then the theory is your 2 theory tests and your class tests. All of that combined gives you semester mark, and then your semester mark plus your exam gives you your final mark. Now, in order to get entrance to the exam, you need a minimum of 50% for your practical component mark, which means that your practicals plus your practical test plus your Practical X, all of that combined needs to be at least 50% for you to get entrance to the exam, which means if you don't submit your practicals and you don't do your test, you're not going to get into the exam. No ifs, no buts, no whys. That's how it is. There's no negotiation with that. I'll get to you now. Then your theory component mark, that's just your theory tests. The other thing that you need is a minimum of 40% for your semester mark. So you could get 100% in your practical mark, but if you don't get a minimum of 40% across your practical and your theory components, you won't get entrance to the exam either. Then to pass the module, you need a final mark of 50% and a minimum of 40% in your exam. So all of those things do get carried on throughout the semester. If you have any doubt, you'll check there. If you're not sure about anything, you can always email us and we can clarify for you. Question? You'll have to talk louder than that. Sorry, I didn't get that. No. So VPL, Virtual Programming Lab, no. You will get a way to do the stuff at the actual computer labs. You'll get the software available to use on your own machine, but there is no VPL. Yes?
I remember last year there was a special case for the verification in a bad example. There's two holes in the
Sorry, repeat again.
I remember last year they said getting a distinction for your SMO to abstract exam.
Oh, so you mean promotion? So there's no promotion. It's no playtime. Now you have to work for your final mark. So there is no booking. There's no booking. So your practical session is there's 3 periods. You're supposed to be there for all 3 periods. I just said that a few minutes ago. There'll be a specific version which I'll talk about more tomorrow, but I can tell you now what we're using is there's no real official version since JDK became open source. We are using version 17, which is the latest long-term service release. But all that information I'll talk about more again tomorrow.
So in Group A, next week lectures are online, right? But what about practical?
So practical sessions will also be online. So right now, tomorrow, Group B will be not in the actual computer labs. Not to say they're not on campus, they'll be on campus, just not in the actual computer labs. So you can still carry on doing it in the other computer labs. There's open labs here in D-Lab. I'm not sure about the protocol or what's happening there, but they're supposed to be open. And then we'll be on Blackboard or Discord to have any questions, discuss any issues, etc. on there. So it's not like we saying that you can't use it. You're still going to be doing the practical sessions. There is talk that, I'm not saying this, it's not official yet, so I'm not sure, but there is talk about saying they're abolishing the rule of 50% in the next few months. If that's the case, then everyone's on campus and we carry on as usual. So at this point in time, tomorrow Group B is at home, next week Group A is at home, away from the venue. I shouldn't say at home, it's away from the venue. Any other questions? Yes. So with Blackboard and raising hands and stuff, that the issue with that, I can, like right now, I can probably go check who's actually raised their hand or whatever. So yeah, you see there is people talking here. So at the moment, you'll see that Mr. Situnga is handling the questions there. And that's because I can't keep swapping over and ignoring everyone just to read one question here. And if the question doesn't make sense, then I'm not going to announce it. Then people are going to read this, get confused. It's new. All of this is new. We haven't done half and half before. It was either full in lecture venue or full online. We haven't done half and half. So I'm not sure. Honestly, I've been teaching for 13 years. I'm not sure. So when we know the answers, we'll let you know. But at the moment, I'm not going to be able to read that and give a class in the full time because, yeah, I only have 15 minutes left to finish my lecture, and I still have to start the actual lecture. So getting between that's going to be a bit of a challenge, something for me to figure out. And what I could try and do is maybe have it on rather ask questions on Discord, and I can check my phone that maybe it doesn't interrupt. But still, we'll have to see. I'm not sure. I'm a lecturer, but that doesn't mean I have all the answers. I have most of the program answers. That's fine, just not lecturing answers. All right. Okay, so if there's no other burning questions, let us just finish the final part of the learning guide. So practical X,
presentation because I guess I'm kind of far away.
Okay.
Did you say that practicals are going to be online?
So, because of the 50% rule, Group B will not be in the computer labs, but Group A will this week. Next week, Group A will not be in the labs, but Group B will. It's just like the lectures. It would be nice for everyone to sit in front of a computer and test the stuff I'm teaching you as soon as COVID decides to go away. And I don't think COVID wants to. All right, so Practical X, if you haven't heard from people that you might know in second year last year, is where we try and basically get you to do a game of sorts. Now I say game of sorts because what we're actually trying to test is your ability to write complete software. Now, not complete software where you're going to try and sell it to someone. If you're going to try and do that, Informatics 3A and 3B, that's where you learn that. Computer science, we're teaching more the science behind things. We're teaching more best practices, design patterns. That's what we're actually trying to test it. So while we are looking at a game, we are more testing that you are actually to be able to program something given a set of certain restrictions. So that's what Practical X is. Now, this is not to say that you're going to get 1 week to do this. This is actually over a longer period of time. There's 2 milestones that you have to do first. You have to give us a design of what you want to try and do, an implementation, a rough implementation of that design, and then the final implementation of that design. Okay, so class tests we already spoke about. We'll try and do them on Blackboard, or we'll see how else we're going to do them. Assessment details, the dates of the tests are there. However, the venues are still outstanding because of the 50% rule and because we want to try and get everyone to write at the same time. We still don't know how many venues we're going to get. So as soon as those details become available, the learning guide will update, and then you'll obviously get that information there. Additionally, you'll all note there is dates for supplementaries. If you are ill or any other reason, valid reason why you cannot write on that specific day, you need to apply, and those are the dates where applications cut off. You have to apply to write. You don't get automatically entered into a sick test if you don't write the main test. So those are the dates specified there. And again, depending on how many people come, because at this point in time, I have no idea how many of you will be ill. So I can't get a venue right now. That will be done close towards the time. And then the last thing is just to note that the exam, if you look at the documentation for timetables, you'll find out what that code actually means. Gives you the session of your exam. But obviously that's much, much later after we're done with the whole semester. So the assessment timetable is there. I have to double check if that link still works because UJ updated their website. But it is there, and you can have a look at when the exam is supposed to be written. All right, so any other questions related to admin around the course? Anything that I've discussed so far? All right, so let's see if I can do a quick lecture in about 10 minutes. So what are we going to be doing this semester is going through, all right, let's fix that. Is we're going to be looking at Java as a programming language. Anyone here have experience with Java previously? Few people. Delphi? Okay, a little bit more. Anyone have experience of a language other than C++? Okay, some of you might have done informatics, so Visual Basic. So what we're going to teach you is another programming language. Now, you might be wondering why. What's the point? I know one, I know everything, right? When you learn another programming language, you learn the concepts better than just learning it under one language. It's not to say that when you leave, you get a degree and you leave, you're just going to write everything in one language. That's never the case. It's always changing, it's always adapting. IT is one of those things, every 3 to 6 months, things change. COVID happened, things changed. IT is in everything. Whatever sector, industry you're working in, IT is there. And it has to adapt to changing things. So we're going to teach you another programming language, but more importantly, teach you how to bring the knowledge you have with C++ and apply it to different language, as well as teach you new things. So we're going to have a look at different programming language categories, because you've only learned about C++. You know that C++ is a compiled language. How do you know it's a compiled language? You wrote code in source files, and then you had to run it through a compiler, which eventually, after a whole bunch of other steps, gave you an executable. But there are other types of programming languages, some that don't need compilation, some that compile in a different way. So we'll talk about that. We'll talk about Java and its design goals and features, and then we'll have a look at comparing Java and C++. So I don't think I'll be able to get to the comparison part before the end of the lecture, but at least let's have a look at the first few slides. The first programming language category we need to talk about is low-level language. So low-level languages, there's basically two types. One is machine code. At the end of the day, the computer you work with only understands one thing: binary, ones and zeros. Now, can anyone tell me what this program does? Anyone? Can't, because it's binary. It's machine code. You have to know which architecture is it for. Is it a 32-bit machine? Is it a 64-bit machine? Is it an Intel processor? Is it an ARM processor? Is it an AMD processor? You have to know all of those things in order to understand what does it actually mean. So it's not something for me or you as human beings to understand what's going on there. So there has to be a way for us to talk to our device to make sure it can do the things we want to do. So that's where the first level comes in, low-level language. That's where the first sort of stage comes in, where we can understand sort of what's going on. And that is assembly language. So assembly language is a little bit higher in terms of not as close to the hardware as possible. It's still hardware specific, but it's something that you can still read. If you look at this program, what do you think it does? That green text should tell you everything. What do you think it does? It prints hello world. That should have been one of the first programs you've written. Hello world. And this is a version, not the only version, a version of assembly that prints out hello world. Now, if you think this is interesting, in Computer Science 3B, I'll see you again, and I'll teach you assembly, where an if statement and a while loop is 200 lines long. Anyone look forward to that? Okay, so you'll see assembly again in the future, but note it's there. Then we get onto the high-level languages. Now, high-level languages, they have structured programming. They have object-oriented design or functional design, depending on which programming language you work with. But they're more akin to us understanding what we're trying to do. It's more easier to read code and know what it actually does. It's more closer to English, which I find weird. Why is English the language used in every programming language, even though English is not the most spoken language in the world? Something interesting for you to think about. So you should know this one. This is C++. You're seeing C++, and you should know what that program actually does. If you read the code, you understand the code, because it's easy to read once you know the actual syntax. If I give you a different programming language, it might look different. It might not seem very familiar, but you can still figure out what it's trying to do. Now, with C++, what you had was source code that you had to compile and link to get executable. So this is a compiled language. If you look at Python, Python is an interpreted language. So interpreted language, it looks through the source code and reads it line by line and executes it. It interprets the source code as you run the program. That's why Python is typically slower, but it can be more powerful in certain circumstances. Then we have something called bytecode interpreted. So bytecode interpreted sort of compiles, it translates into a machine-independent code format known as bytecode, and then that gets interpreted on a virtual machine. So that's sort of like the hybrid between the two, hybrid of compile and interpreted. And this is where Java falls in. Java falls in as a bytecode interpreted language. And we'll talk more about that bytecode in the next lecture. Then you can see a small example. Again, hello world. There's some syntactic differences. You can see it doesn't look like C++. Obviously, it's not because it's Java. But you can see some similarities, some differences that you might be able to identify very quickly. So compilation, which you should have seen with C++, you have your source code, you have a compiler, it compiles it down to machine code or object code, then it goes through a linker, any libraries that you have used, it links it together, and that gives you a runnable executable. That's what you know. This is how C++ does things. With Java, it's a bit different. You get things that compile into class files, you get a class loader, execution engine, a native interface, all of the things somehow combined together to give you a language that you can write code once and run on any platform that the Java virtual machine is available on. Now, what is a Java virtual machine? Something we'll talk about in lecture 1. Note, we did start with lecture 0 because this is computer science, not informatics. So lecture 1, we'll get into more details there. In terms of Java, the language itself, when it started in the 90s, it wanted to be something that could work ahead of something like C++. It wanted to be something that people who program in C and C++ could identify with, but it wanted to do its own thing separate away from them. So the design goals, it wanted to be simple, object-oriented, so that's something that you've done, classes, working with objects, etc. It wanted to be robust and secure. So robust means it doesn't crash your machine when you run. Secure, you might have seen that Java is one of the more insecure languages. There's a lot of vulnerabilities that happened over the years. But as they progress to open source nature, then vulnerabilities became quicker to fix. But the most important point for Java is architecture neutral and portable. What that means is I write code once, it will run anywhere. Whereas something like C++, if you write code on a Windows machine and you use Windows-specific things, it will only run on the Windows machine. It will not run on a Unix machine, it will not run on the Mac machine, it will not run on an Android phone. Whereas Java, it can be portable, it can run on those different platforms. High performance, over the years, Java has become more performant, not as on par with C++ yet, but as far as anything else is concerned, C and C++ is the fastest languages you can get, full stop. No other language can compete with it. They do get close, they do equal, but they never get better. So then the last point there, interpreted, threaded, and dynamic. Threaded, we'll talk about threading and how we can run the same or two pieces of code at the same time, and dynamic in the way it links together and works together. So features, we already sort of spoke about these things. I'm not going to go through that again. So that was the design goals. That's what they wanted to do. These are the things it actually does. And then the last thing I'm going to talk about, because we don't have time to get through the comparisons, is the different editions. So you get 3 major editions. 2 of them use widely. The last one, I'm not sure how widespread it is. You get something called Standard Edition, which is what we're going to be using to write Java source code. Then you get Enterprise Edition. That's used on an enterprise level. So these are used in big companies, and they have extra things to make sure that it works for them. And then you get the Micro Edition, and this is where, before the age of Android, before iOS was a thing, you had something called feature phones, and feature phones ran Micro Edition. Not to say that it's not around anymore, it still is. You still have things like Internet of Things devices. Anyone know what an Internet of Things device is? So a Fitbit. It's a small device that connects to the internet. If you have a smart fridge, a fridge that can order you milk. Anyone wants a fridge that can order you milk when your milk is finished? Anyone? How about a toaster that will print the weather on your toast as it toasts it? Anyone? No? Well, those are Internet of Things. There's more examples, but that's the ones that are coming to mind right now. Other things are just a bit more complex to talk about, and obviously I can't get through all of them right now. So when we're working with the Java JDK and the JRE, so there's two components, like I said there, the JRE, runtime environment, what you need in order to run Java, and then you have JDK, Java Development Kit, what you need in order to create Java applications. All right, so I'm going to end there. So you can go and read the rest of the lectures. Lecture 1 is available already on Eve as well. You can have a read through that. We will be going through it in class. I will be uploading the practical lecture for tomorrow, so you can have a read through that. If there's no questions, which I see people already running away to leave, I will see you all tomorrow. Thank you.